Hello everyone, this is Dr. Pandimina, Assistant Professor, Department of Physics, SRM, Madurai College for Engineering and Technology. In this video, let us see about imperfections in crystals. First, let us discuss about crystal. What is a crystal? A crystal is a regular three-dimensional periodic arrangement of atoms. What is meant by imperfections in crystals? In an ideal crystal, the atomic arrangement is regular and continuous. But in real crystals, the orientations may be slightly altered. So, the disturbance in the regular orientation of atoms is termed as crystal defects or crystal imperfections. That is, any deviation from a perfect structure is termed as defect. So, how come these imperfections are coming from? The common imperfections may be due to chemical impurities, lattice vacancies, and extra atom not in a regular lattice point. The crystal defects can be divided into four types based on their geometries such as point defect, line defects, surface defects, and volume defects. Point defects. This point defects is further classified into three types such as vacancies, interstitials, and impurities. First one is vacancies. When one or more atoms are missing, then it is termed as vacancy. There are different kinds of vacancies such as Schottky defect, Frenkel defect, color centers, and so on. The figure on the left side shows the Schottky defect, in which a pair of positive and negative ions are missing. This type of defect is known as Schottky defect. The figure on the right side gives the Frenkel defect, in which an atom or ion occupies an interstitial position. This type of defect is the Frenkel defect. The next one is interstitial defect. An extra atom occupying interstitial space within the crystal structure without removing an atom is termed as interstitial defect. There are two types of interstitial defects. One is self-interstitial defect, another one is foreign interstitial defect. Self-interstitial defect is a one in which atom from the same crystal occupies interstitial position, whereas foreign interstitial defect is a one in which an impurity occupies the interstitial site. The next one is impurities. Foreign atoms added to a crystal lattice are known as impurities. There are two types of impurity defect. One is substitutional impurity defect, another one is interstitial impurity defect. Now, what is meant by substitutional impurity defect? It is a one in which a foreign atom replaces a parent atom in the lattice, which is shown in the left top figure. Next one is the interstitial impurity. It is a one in which an atom occupying the empty space in the crystal without disturbing the parent atom, which is shown in the figure on the right top. So the figure clearly gives the substitutional impurity defects and interstitial impurity defect. The next type of defect is the line defect. The defects due to dislocation or distortion of atoms along a line are known as line defects. This line defect are also termed as dislocations. There are two types of line defects. One is edge dislocations given on the right side and another one is screw dislocations given on the left side. Edge dislocation is a missing half a plane of atoms, whereas screw dislocation is a helical displacement of atomic planes. The next type of defect is the surface defect or plane defect. The defects on the surface of a material are called as surface defects or plane defects. Surface defect is also known as two-dimensional imperfections. The surface defects are due to a change in the stacking of atomic planes on or across a boundary. Some important internal surface defects are grain boundaries, tilt and twist boundaries, twin boundaries, and stacking fault. Grain boundaries are the regions between differently oriented crystal grains, whereas twin boundaries are the mirror image regions within a crystal. And stacking faults are the errors in the regular atomic stacking sequence. With this, I'll finish the imperfections in crystals. I have given a clear cut of view for the classification of imperfections in crystals in this video. Let us see in the next video. Thank you.